Welcome back. I hope you are doing great. Let us continue our journey aggregations by using statistical functions. We have seen as a part of our conceptual class, there are different statistical functions like variance, standard deviation, and we do have skewness and kurtosis. We do have covariance and correlation. We see hands-on examples for all these statistical functions. By the way, we need to have a data frame to execute or to use the statistical functions. I hope you have already created a data frame with a DF retail set. If you haven't, we'll create one. Please go ahead and create. Since we are reading multiple files, it is taking time as we have already observed in our previous hands-on session. So let's go ahead and check DF retail. Let us show, and some 5 records are enough. There you go. We have all the records and all the columns. You can also check the schema. That is how the schema looks like. To use the statistical functions, we got to import them first. As I have already been indicating, you have a way to import all the functions together, but I prefer you guys to import the functions one by one so that you know which function you are using. Let me go ahead and import a function. We are good to go. Let's import all these functions. These are the inbuilt statistical functions. Okay, I have imported these functions. Let's go ahead and use the statistical function on column quantity. I'm going to reuse it from our previous class. Okay, here instead of average, I'll go ahead and say variance population. Okay, and this is as simple as that. I'm going to calculate a variance of population on the column quantity of DF retail data frame. Let's execute this. There you go. It did a pretty awesome job. We can see the variance of the population is 47559.30. Picking on the discussion what we had during the conceptual class, for some of the people, statistics is awesome. For some of them, they really don't like the statistics. Now the question would be, do we really need to know the statistics in depth? Not really. Being a PySpark developer, you already have the inbuilt functions, you got to use them. But you should definitely know these are the different statistical functions available as a part of the PySpark. But if you do know, if you have an interest in statistics, if you want to drill down more, you can do that. That will definitely help in your development. Now that we calculated only one variance, what we'll do is we'll go ahead and calculate all these statistical functions. There you go. We have constructed the whole statement. Let's go ahead and execute this and see how does it calculate the different statistical parameters. You can see variance of population and variance of sample in this data set, it is same. Okay, same is the case with standard deviation of the population, standard deviation with the sample. As I said, do you need to decipher it? You need not. It's a job of a data analyst in a project. But if you really know how to decipher it, it's good. Having understood these things, let us move on to a couple of functions called skewness and kurtosis. Let me import those functions first. Yes, I did. Let me go ahead and revisit. So I will take this guy and repurpose this for skewness and kurtosis. Let me take out these two guys. Okay, that should be enough. Okay, here what I will do is I will mention skewness and kurtosis. Skewness is something which you have heard of. Is the data is positively skewed or negatively skewed. Kurtosis is a tail of the data. Let's go ahead and execute these two statistical function on the quantity column in DF retail data frame. Okay, you can see. So skewness here it is negatively skewed. Okay, kurtosis, this has a lot of value. The tail seems to be long. Wonderful. Let's go ahead and see what are the other statistical functions we have. We do have covariance and correlation. Let's go ahead and execute them as well. First, we got to import them, import the functions. The functions what we're importing are correlation and covariance population, covariance sample. I'm importing them. Okay, I imported them. Awesome. Let's go ahead and build. Let us repurpose this and execute these functions. Only thing is, whenever you use the correlation and covariance, it is always between the two columns. Please do remember that. What are the functions we have seen so far? All of them are for one column. In case of correlation and covariance, it is always for two columns. So let me add two columns here, correlation, and then I got to give one more column here. Let's go ahead and give the unit price. Okay. And then what I will do is I will change this guy to covariance sample. Okay, and again I'll calculate this on the quantity and unit price. I will copy this whole guy and then instead of sample I will rename it as a population. Awesome. We have built the statement. Let's go and execute this. We are calculating the correlation between the column unit price and the column quantity in DF retail data frame. There you go. You can see the correlation between the quantity and unit price is negative. So what it means is they are negatively correlated. What it means is when the unit price is more, the quantity is less. When the quantity is more, unit price is less. On the other hand, you can see the correlation of the sample and correlation of the population seems to be same in this particular data. The last thing what we'll cover as a part of the hands-on is we'll cover two of the functions called collect set and collect list. We'll explain them as and when we execute that. So let me import those two functions first. The functions are collect, set, and collect list. I will import them first. Done. Then the next step is constructing a statement. The statement is ready. I executed this. You can see here the collect list is collecting all the records from this particular column called quantity and making it a list. You can see 48, 20, 24, 24 and all these things. Okay, so what it means is it is even collecting all the duplicate values also. On the other hand, collect set only collects the unique values. It removes all the duplicates the record and makes a list out of it. Awesome. We have seen some of the important statistical functions which are inbuilt in PySpark, which you can use as a part of your project. Please do practice. Thank you.